Hello, this is simply about networking protocols, and today I'll tell you about OSPF basics. Using OSPF v2, there is OSPF for IPv4 version. Standard that describes this protocol and feature is RFC 2328. In this video I'll tell you reason for OSPF design at all, autonomous systems, what is areas, how they processed, what is boundary routers, what is backbone area, and provide you simple routing scheme within areas and between autonomous systems. So autonomous systems, those are set of the networks and all environment required for network functionality that is owned by one specific organization. This network means some network prefix, and environment means all the set of routers, switchers, links, all the required to transmit the data within this network. You can, in your imagination, you can take it as, for example, some specific mobile operator is the autonomous system. Well, then it's obvious that autonomous system contains huge amount of routers. If we would build routes between each device in the autonomous system, then each device would have huge table of the routing, would spend huge calculation resources on calculating this, supporting this lookup, reacting for some topology changes, and so on and so forth. Let's check it on the example. We have autonomous system boundary routers, and those autonomous system boundary routers transmit to the system information about all external routes. It means for all neighboring autonomous systems, they transmit to our system list of networks that those neighbors contain, and devices that could transmit traffic to those autonomous systems, to those networks. So each device within an autonomous system should contain this information, manage, look up, and periodically update this information, plus routes to those boundary routers. That is extremely big. Also boundary routers transmitting information about our autonomous system to the neighboring devices, to neighboring autonomous system, so they could build necessary routing routes and use them. Again, very important. Why BGP is so complicated? Because usually BGP is used to exchange this information. The BGP is so complicated because it is configurable which information about which networks to transmit, to apply, and to send to the devices within autonomous system. Not all information is needed to be visible to the neighbors or to the devices within the autonomous system. Then OSPF appears, and OSPF allows to split autonomous system to isolated areas. Isolated areas means that devices within this area know routes or build routes only to devices within this area. Everything else within this autonomous system, they treat it as external networks, and they could use boundary routers of the OSPF area as a default router for that. So they don't need to have information about each router and about each network and subnet within autonomous system. They are working with networks and subnets within area, and everything else is treated as external to this area. For example, we have an area we have devices that are colored with single color that are internal to this area, and devices colored with two colors that are boundary routers for this area, for this OSPF area. Similar to the autonomous system, boundary routers for the area, collecting external information and send them to the devices within area to inform that external networks can be accessed by those devices. And they are sending information about internal networks to the neighboring area so they could process it. Well, for the neighboring area, information that our boundary routers or boundary routers of our area sending to them is external networks. So they collect this information, process it, and start using what is the most important feature of the boundary router. Most important feature of the boundary router is merge, routes merge. What does it mean? It means that in case we have a possibility to merge networks that are part of our area into single network with shortest prefix, it will be done. For example, networks with prefixes 10.10.18, 10.10.20, 10.10.25, 10.10.30 can be merged and transmit as 10.10.16 with mask length 20. You remember from my video about IP, how it works, but let us just reminding. So we have networks with prefixes 10.10.18, 20, 25, 30. If this third byte can be split to binary, you can see that we have one common part and one part that is changing. Thus, not changeable common part, this is prefix, and it became 10.10.16 with mask length 20, because now we have 20 only, and everything else can be manageable. Then this information, so we, instead of 4 entries, have only 1 entry that dramatically save the resources of the devices. So again, one of the most important thing for the boundary routers, of the OSPF area, this is merge of the routes. And another important part is boundary routers are the part of the backbone area. This is so-called area 0, or because most of the vendors require to name OSPF areas in IP form, this is area 0000. Backbone devices or devices that are part of the backbone area. Well, eventually this is any device that have interface to this area, but most logically to have the boundary devices that allows to transmit traffic between different areas and to the boundary of the autonomous system. It means that devices in backbone area needs to be connected, but this is not always possible to connect directly by single link some devices that are boundary to some specific networks, and here virtual link appears. Virtual link, this is not direct link or tunnel. You can treat it as a tunnel, similar to tunnels videos that you remember. So this is a tunnel between devices that are part of the backbone area, and those devices transmit traffic through this tunnel to each other independently from actual environment that is used to transmit those signals. in reality. One important link for the important condition for the virtual link can be configured only between interfaces in the same area. If interfaces of the boundary devices or some devices, backbone area devices in same area, the virtual link can be created. If they're in different areas, it's not, because areas are isolated and we cannot pass the traffic between areas without usage of the boundary devices. So, how routing scheme works using OSPF areas? Let's check it on two examples. First example, we have two neighboring areas and we need to transmit traffic from the device of one area to another. These devices were about boundary router of this area and sends traffic there. Boundary router, since those are neighboring areas, just passes this traffic to the neighbor area. Here we have a route to the destination device that we are looking for, and traffic is transmitted to this destination device. Very simple. So we have routing within area and routing within area. In case those are not neighboring areas, or we need to transmit traffic to another autonomous system, it adds one additional step in between. So we still have routing within area to the boundary router, and then traffic is routed through the backbone area. This is how backbone area is used. Those can be virtual links or those can be actual links, doesn't matter. So traffic is being routed until it reaches boundary device that can transmit it inside the specific area, or in our case, inside the specific autonomous system for the further processing. In this autonomous system happens same as in our autonomous system eventually. That simple. Thank you. Have a great day.